I think I will move on a little bit to the end of my presentation here, because we will come back to more about challenges and opportunities later in the Q&A session. But I would like to highlight some of the things that we have seen that are in great need in order to develop district cooling schemes, and it is capacity building. And it is both professional capacity building for government agencies and so on, in order to be able to manage these kind of programs. I don't want to say just projects, but programs accelerating the development of district cooling. That is one part of the capacity building required, and that we are to a large extent in great need of, but also the vocational training, because as we are expanding this sector so rapidly across the region, we also need the workers of the future. So what we have done in APUEA is that last year we started the APUEA Academy, where we are supporting cities to build their capacity, being able to manage these kind of programs, and also work together with the academia and vocational colleges and so on. It's not only to educate engineers. We need a lot of different kind of workers here. We need welders, we need construction workers, a lot of things that are related to these kind of developments that are something in between energy systems and infrastructure projects. It's quite complex, large investments that should last for a long time. We are talking about not lifespans of 10 or 15 or 20 years. We're talking lifespans up to 50 years. So the quality is of great importance when it comes to both designing but also implementing these kind of projects. A few words in the end about Vietnam. We're really glad to see the work from the Minister of Natural Resources and Environment that we will hear from here just after me, who has included cooling and extreme heat in the NDCs, which is really important because that really helps us to start talking about district cooling and other cooling, efficient cooling technologies. So that is a really, really great step. And we also see the urban cooling action plans taking place. And this is something that is very important, not only for Vietnam, but also for other countries, I would say in the sub-region of Southeast Asia, in the region as Asia Pacific, but actually also globally. There is too little energy planning practices in place around the world, and it's very important to start with the planning. That's how we can really figure out where district cooling is feasible, so that we can then develop the city accordingly, so that we are really taking the advantages of district cooling. We will hear more about the benefits of district cooling, as I mentioned, from the previous speakers. So with that, I will like to thank for getting the opportunity to provide this overview of the district cooling market in the region, and hand over to you, Peter.
Thank you very much, Michael, for sharing these insights. And I think it's great to see an outlook of district cooling markets, other district cooling markets in the ASEAN region. Thank you very much, Michael. Now we'll continue with our second speaker today, Dr. Lim Young Wei, who is the head of division for Greenhouse Gas Emission Reduction Center. Apologies. He's the head of division of Greenhouse Gas Emission Reduction and Ozone Layer Protection at the Ministry of Natural Resources and Environment. Dr. Lung will share insights on climate changes responses, mitigation and adaptation, legal provisions on greenhouse gas mitigation and ozone layer protection. Welcome, Dr. Lung. The floor is yours.
Okay, thank you very much, Peter, and good afternoon. Thank you for having me. So what I'd like to share with you today is that recently issued legal documents regarding the GHG mitigation and ozone layer protection in Vietnam, and probably some of you already know about it, but I just want to go a little bit more in terms of the implication for district cooling in Vietnam as an objective of our seminar here. As you know, by the end of 2020, we have the revised law on environmental protection. It's co-revised, but in fact, that there's the whole new law on environmental protection, especially on climate change. We have Chapter 7 that dedicated for climate change, and in which there's some particular articles on GHG emission reduction, and very much related to our efforts on climate change response recently, and also to implement our NDC, in which that is recalling, and the efforts to reduce the GHG emission or energy use in several sectors. And after the law, of course, according to our system, that we have the decree to guide the implementation of the law, and by earlier this year, that we have the decree 06, which took us probably about more than 6 years, seeing our law on environment protection. The first one came out in 2014, and then we have issued the decree. Not really issued. We have developed the decree on GHG emission reduction, but it's keep getting delayed because of the changes in the international climate change negotiation. So it's only came out this year to support us in terms of not only the implementation of the law, but also the COP26 results implementation that Vietnam's already committed. And then I will talk a little bit on the list of entities that might carry out the GHG inventory, which is the first step towards that having the allowance to emit for GHG emission at the facility level, and also some regulation on MRV and inventory system. A little bit on the carbon market, and also layer protection, which is actually very much related to this recalling that we are talking about here as well. Okay, so we all know that, well, we have 3 main articles in the law, 91, 92, and 139, which is very much related to climate change and GHG emission reduction, and ozone layer protection, and the carbon market development, which can be very good tools for this recalling as well. I will come back to that later. But then we have the decree 06, which again that provide very detailed responsibilities and also measures for different levels of GHG emission reduction, from national to sectoral and to facility level. So we got several chapters there, which one chapter is dedicated to GHG emission reduction, and they mentioned the responsibility of sector, in which that the sector on this recalling that can cover, for example, building and construction or energy sector, and also on energy efficiency and renewable energy as well, to implement the GHG emission reduction obligation towards our objectives to reduce GHG emission in Vietnam in general. The things I want to take to emphasize here is that because it took us so long for the decree to come out, because we got to take into account what we committed in the COP26. Just before COP26, that we submitted our updated NDC, which we increased our ambition to reduce GHG from the previous NDC. But at COP26, that with the net zero goal commitment from the government of Vietnam, as our Prime Minister already stated during the event, then we have to change the way that how we go forward to achieve that statement, that goal to reach net zero. So the responsibility of different stakeholders, including at the national level, sectoral level, and facility level, in the decree seems a bit tighter, and the roadmap towards that kind of goal is also a little bit quicker compared to what we imagined, what we envisioned before. So that included all kind of responsibility for GHG inventory at national, sectoral, and facility level, and the measures, the action plan to reduce GHG emission, and also the MRV system, not only to track the NDC implementation, but also to support facility to participate in different types of carbon pricing mechanism in the near future as well. So we divided into two periods from now to 2025. So basically, that is kind of a buffer zone for all of us, from the national to sectoral and facility level, to understand better on the requirements of the laws and the decree, and also the situation and of our net zero goal endeavor towards 2050, and is to improve the capacity of all the relevant stakeholders from now to 2025, and also to support line ministries to have time to do all kind of research and to issue a sectoral policy as well. For example, all guidance on GHG inventory and MRV at sectoral and facility level needs to come out. So for inventory, that we very much relies on the IPCC 2006 guidelines, but for MRV at the facility level, we have to use different types of guidance. For example, GHG protocol, for example, which I believe that this recording is using a lot as well. And of course, along with that, we need to improve the awareness of the facility at facility level for them to develop their action plan and also measures to reduce GHG emission, including all sort of energy efficiency and saving at the facility level as well. So what we of course, once that they have done that, if they have any kind of efforts that they need to be recognized, the MRV system is quite important as well. So it's been talked and researched a lot already at the different levels, from national to sectoral and facility level, but it's not consistent in a system that would support a tracking system at the national to sectoral and to all the way to facility level. So the Decree 06 provides that kind of a system for us, and also using consistent system to report from facility to the local level at the provincial level through DONRE, for example, or maybe other departments at the provincial level as well, to the line ministries, and finally to MONRE to finalize everything and to report at the national level. So the MRV system is to, first of all, to support the line ministries and the government to track our efforts to do that, and again to recognize the efforts from facility on their efforts on energy efficiency or GHG emission reduction at the ground level as well. This is a very new thing, that we have the list of entities that must carry out GHG inventory, and that's never been done before in Vietnam, and never been done in a way that legally binding. Before that, so many sectors have tried to calculate the GHG inventory at the facility level already, but now that what we need to identify is the loss emitters. So this is the first time, so we came up with the criteria to identify who are those that needs to implement the GHG inventory and report to relevant stakeholders and relevant the authority. So there's a few identification of the different sectors there, and we base very much on the current existing database that we have in terms of energy use. So, and that would include buildings and some of the district cooling facility as well that we have in terms of the use of AC and other cooling equipments, and if they use more than 1,000 TOE at the facility level per annum. So what they have to do is, from now until 2023, they only have to provide activity data to the line ministries. So we will help them to calculate their GHG inventory in the most simple way, using Tier 1 methodology. But from the next time, from 2025, when they submit the second report, GHG report, they will have to do it themselves, and using Tier 2 as best to report to the local government and then to Lam Ministry and Monterey. So the problem with that is that for the business is that they in terms of district calling, that we've been working with different Lam Ministry, for example, MOIT and MOC, and first of all, it's not really recognized as one of the sector within the NDC, because as you know, the NDC is identified accordingly to the IPCC and UNFCCC classification. So district cooling is part of the energy sector only, and it's not, in terms of inventory, it's not even, we haven't got any kind of methodology to identify the emission from district cooling equipment, for example, or facility. So that is that needs to change, and that needs to we need to come up with methodologies and to find a way to integrate that into not only the energy sector, which is already done, but also other sectors as well, for example, the construction sector. And that would give us the advantage to the facility that they are recognized in terms of their efforts to at the domestic and also international level by using, if they want to shift to a technology, more efficient technology for this cooling, and they would have the advantage in joining the domestic and international carbon market in the future, which actually forming now at both international and domestic level. And of course, they increase their competitiveness in participating in international market as well. But the problem is that those limitations, as I already mentioned, that they need to understand better on the regulations and their obligation to provide reports to GEG inventory, for example, and action plan to reduce GEG through energy efficiency or some other measures that they would have as well. And of course, that the cost for them to change the technology would be quite high at the moment. But for the long term, that would be better, and that needs to be assessed properly as well. Some others on the carbon market, I'm going to go through it quickly, but there's been a lot of efforts in developing market and involve the facility within that decision 01 of the Prime Minister, which of course being updated every 2 years, and that there will be a lot of companies that or manufacturers or even user of district cooling equipment would be able to join our ETS or the National Correcting Mechanism at the later stage, which will be piloted starting by 2024 and then going to a full operation a couple of years later. I'm going to skip this. And of course, on the ozone layer protection as well, the district cooling that related to very much on the use of air gas in the equipments, but with the decree, there's a lot stricter regulation on the use and the management of all the substances in using in the ZOS equipment as well. And through that kind of that is governed by another the international laws and also the Vietnamese law, but it would have with the Kigali amendment that all types of GHG emission within the district cooling equipment's control and management needs to be controlled as well, and that can be a good way of managing and contributing to the net zero goal. So, and of course, in others activities and other articles and regulation on the promoting the involvement of relevant stakeholders there as well. That is actually everything about the Decree 06. But the point is here is that for the district cooling activities now, it seems new in Vietnam, but in fact it's not at all. And what we need to do is to change what the perception of Lam Ministry by looking at the district cooling work that we are trying to do. What I've been working with the Ministry of Construction, for example, I noticed that the latest standard TCXD on AC is in 1999. That needs to change. I think that that's something that our project can help supporting MOC, for example, to change to update their standard, and that probably the best way to expand or to the impacts of our work on district cooling equipments and design. And that's a few of my thoughts there. And thank you very much for having me. Thank you.
Thank you very much, Dr. Leung, for this interesting presentation and insights in policies and regulation in terms of greenhouse gas emissions. I think it's very interesting to see, and I understand that there's a lot of changes coming now since COP26. But I'm also very, glad to hear, the awareness of district cooling that exists, among policymakers. So, yeah, we're looking forward to see the continued development of policy that might help promote district cooling a bit more. Thank you very much again. I want to move over to the next speaker. Our third speaker today is Mr. Lim Young Wei, who is an Assistant General Manager and Business Development at Keppel District Heating and Cooling Systems. Young Wei will share his insights on the topic, developing sustainable district cooling systems in Vietnam. Welcome, Young Wei. The floor is yours.
Hey, can you hear me?
Yeah, we can hear you.
Yeah, the screen is okay. Yeah, okay. Hey, my name is Young Wei. I'm from Keppel District Heating and Cooling System. So today my topic for today is on developing sustainable district cooling system in Vietnam. Yeah, so I'm from Keppel Infrastructure. We were established in May 2013 for the integration of Keppel Energy and Keppel Integrated Engineering. So we invest in, develop, own, and operate competitive energy and environmental infrastructure solutions and services. So in the services that we have the power renewable side, which we do power plant and also solar systems around the world. And also for environment, we have the waste treatment and water and wastewater treatment facilities. And then we have a district heating and cooling provider services in Singapore, Thailand, and in China. So we also do distributed energy services, EV charging, energy storage system, smart microgrid, green hydrogen, and also developing technology in carbon capture and storage. So I think in the snapshot of Keppel Infrastructure service offerings, we are a one-stop customer-centric energy solution for attaining net zero targets with zero capex, efficiency improvement, green offsetting, and smart operation. All these translate to long-term cost saving and carbon abatement. So for our cooling services, we mainly focus on two segments, which is the district heating and cooling. So I think the topic for today, where we invest, design, build, own, operate large-scale district cooling system in major business and industrial parks. So we do this in the form of centralized chiller plant to distribute cooling loads in the form of chilled water to multiple buildings. So what we deliver to our customers are space savings and upfront reduction in capital expenditure, then up to 30% higher energy efficiency translating to lower carbon footprint. I think as a point to what Dr. Loon has mentioned, so district cooling is able to bring about efficiency, reduce greenhouse gas, and so this 30% energy efficiency will translate to that greenhouse gas reduction. So other than district cooling, we also do retail cooling, where we offer chilled water services for individual building that falls outside the district cooling zone. So essentially, we also are able to deliver the benefits of the district cooling in terms of the improved efficiency, and we also undertake the investment and operation of the plant. So Keppel DHS is the largest, first and largest district cooling player in Singapore. So we have a combined plant capacity of 70,000 tonnes. So this is a snapshot of our district cooling portfolio. So we have 4 plants under operation in Singapore. There's the Changi Business Park, Woodland plant, Biopolis and Mediapolis. And we also have the Bulim Jurong Innovation District plant under construction now. In Thailand, we are building the Samyen Bangkok plant under a JV with BCBG and teams. And also we are operating the Tianjin Eco-City DCS plant. And this also have a heating component. Just a snapshot of our portfolio. So we deliver long-term impact with our clients. So we have 170,000 R-ton design capacity across our district and retail cooling portfolio. We serve more than 70 developments, and we have 20 years track record serving our customers with zero downtime. So currently we have a core presence in 3 core countries. So these are Singapore, Thailand, and China. And we plan to expand in the Asean region. Of course, Vietnam is one of our key markets that we plan to expand to. And we serve a wide coverage of industries, data centers, industrial offices, retail, educations, and we serve a wide range of clientele, from the banks to the industrial parks, semiconductor players, and hotels. So just a snapshot of what we can do with our relevant capabilities and experience for the end-to-end solution provider. So increase operational and financial efficiency. So to compare against what existing client, if they were to do a cooling system by themselves, we will save typically about 10 to 20% cost saving with no upfront capital, with energy saving of more than 20%. So we also bring you through what a client, if they were to do a DCS project or even an in-building system by themselves, they need to invest, raise capital, manage payment process. Then this include maybe debt on the balance sheet. They need to come up with their own design, including getting a consultant or EPC to design in-building HVAC system. Then manage the entire construction or retrofit system, including drafting, calling, and awarding a tender. Then owning the system and making sure that they have to comply with the local regulation in terms of efficiency and upkeep. Then do their own operations and measure on the reliability improvement and the system efficiency improvement over the duration of their buildings and developments. So the benefit of coming together with Keppel managed process is that when they outsource this as a district cooling process, they get long-term saving of 10 to 20%, zero upfront capital, flexible payment mode, and then in terms of operation, they get improved reliability, zero maintenance repair, 24/7 support. And also in terms of sustainability, so we improve efficiency of up to 30%, and we adopt the low global warming potential refrigerant chillers, which will help to mitigate any ozone loss in the environment. So we do also a showcase of our One North DCS plant. So this is a combination of our Biopolis and Mediapolis DCS plant. So it's a showcase of enhanced efficiency, reliability, and energy security. So we have a combine of the 8,000 R-ton of design capacity in these 2 plants, which are interconnected. It serves critical loads such as R&D hubs, our broadcaster MediaCorp, and we cross-supply for our thermal energy storage tanks. We adopt proprietary smart optimization software, leading to 10 to 20% cost saving, 30% efficiency improvement, and CO2 saving. And our plants are all certified in terms of Singapore standards, in terms of the Green Mark Platinum level. This is one of the highest Green Mark level that we can achieve for buildings in Singapore. And all our customers are able to enjoy this certification by just connecting to the DCS plant in terms of their chill water side of the scoring. So our buildings, our customers also enjoy, because of the DCS plant, repurposed rooftop, and they can develop very iconic buildings. So this include for the Star Wars fan, the Sandcrawlers buildings. So this MediaCorp, which is our broadcasters. We have a lot of global HQ companies. We have adopted DCS like Wilmar Internationals, Razer, Southeast Asia HQ, which is gaming mouse accessories, Rochester Common buildings, and the Solaris building, which are all iconic developments in Singapore. So other than the DCS portion, so what stands out, Keppel DCS stands out in terms of our offerings, that we also adopt proprietary technology in test tank, though we call it phase change material. So with this, through our R&D effort with our National University of Singapore, that results in greater efficiency and better energy management. So as you can see, with thermal energy storage, it helped to reduce the peak load of an entire development, that shave a peak load of about 3,500 R-ton, then it can shave off to about less than 2,000 R-ton. So what this translates to is leverage on the peak off-peak tariff to charge out the tank during off-peak hours and discharge chilled water during peak hours. Then coupled with our KDHJS optimization program, which we call UOP, chiller can run at their optimal load, and combined with our patented test tank technology, which uses novel phase change material, we can boost the energy efficiency of the DCS plant. So this has been piloted in a large scale in our Changi Business Park plant. So the test tank incorporates PCM within the existing chiller system. The PCM releases cold energy by changing from solid to liquid when demand is required. Then the cold energy distributed via chilled water to buildings at our Changi Business Park development. So some of the key benefits, it has 3 times more carrying capacity than chilled water, resulting in greater efficiency and space saving. And we have a 10% cost saving achieved during our trial at Changi Business Park plant. So we also have this UOP program at our Keppel Energy Transition Center. So this UOP is a optimization software. What it does is that it acts as a KTC is the nerve center that controls all the Keppel infra, cooling, PV, and EV assets. It also duplicates the digital twins of assets. Then this capability allows us for accurate data collection and monitoring in order to provide analytics and insights across all the plants that we have, be it in Singapore, Thailand, and in China. And it has 24/7 real-time smart optimization software incorporated for better energy management by leveraging aggregated data from the system to improve asset performance. So what is the benefit that we bring to our customers is that it allows us to have fault detection and diagnostic. So we monitor plant equipment health, allowing preemptive correction to minimize operational disruptions. It also allows peak load management. So it analyzes system and adjusts the load to operate optimal cost and efficiency. And we also allow peer benchmarking, which we track asset performance in relation to other assets on sustainability and energy, and providing suggestions to achieve goals in both dimensions. Next, I want to actually show you all a video on how we use this software and digitalization program to monitor performance in our plant. So just a snapshot, we show you so this is our one-off plant in Singapore, where it's interconnected between our Bio and Meteopolis plant. You can see the flow of energy between the plants serving our customers. And when you click on our software, we can see the plant in terms of the setup, where the cooling towers are. This also applies for Meteopolis plant, where we can also zoom in and see the cooling towers, the piping, and how our plants are set up. Next, I'll skip to so we also are able to see a zoom in of our plants. So this is our Meteopolis plant, where we can go to our plant level and see our plant in terms of where the cooling towers are, the chillers, and we're able to see, let's say, any improvement where we can install new chillers, pipings, and allow us to witness it in real format. So this is our digitalization twins effort that we've done during the last year. So other than our digitalization software, so even for our plants, so this is our Changi Business Park plant, we adopt sustainability solutions. So our plant, we also put in like solar panels and also green facade. So keeping in mind for sustainability solution in mind, resulting in 50% reduction in water and energy consumption. And then we received the BCA Green Mark for positive energy buildings. So in our building itself, we can generate more than 65,000 kilowatt hour per year through our BIPV and 60% reduction in energy savings. And then we adopt the insulation of 37.7 watt per meter square. We consider a low ETDV and WLR value with minimum glass facade. Then for lighting, we adopt some pipes, occupancy sensors, and LED lights. And rainwater harvesting. All this leads to our decarbonization in our district cooling plant. And then we received the Singapore Green Labelling Scheme and Singapore Green Building Certification Sustainability Materials in terms of our construction. So to summarize all our offerings, so Keppel is a Southeast Asia leading energy as a service player. So we have an unparalleled focus on sustainability and enablement, from product innovation to customer sales. So we do this through a supply of conventional power, renewable powers, and going forward, we could also bring in electrical energy storage system, green and blue hydrogen, and then decarbonization, we can do RECs, carbon credits, virtual power plants, and then leading for customer in terms of net zero roadmap, energy auditing, and baselining. So for measurement of their sustainability goals going forward, cooling, as explained in our slides, EV charging, and also for energy management system, payload management, and energy analytics. So all these is the key Keppel differentiators in the best sustainability and environment advising. Then we bring about our Southeast Asia expertise and network and most complete end-to-end offerings with flexible financing as well. So yeah, thank you. That's the end of my slide.
Thank you very much, Young Wei, for that great presentation. I think you provided a lot of insights and inspiration here, what can be done in the Vietnam market in terms of implementing district cooling. Thank you very much for that. I want to remind everyone that you can ask questions to the speakers. So I think the best way is to do that is to write down your question in the Q&A box, and then we will address it later during the Q&A session. Okay, we'll move on to our fourth and last speaker today, Mr. Adrian Lim Hockhank, who is a general manager at KGTS. Adrian is here to speak today on the topic of district cooling as a service. Welcome, Adrian. The floor is yours.
Right. So Peter, just let me share my background, share my screen.
Sure.
Right. Can you see my screen, Peter?
Yes, can see your screen.
Okay. Oh, just let me change that. For some reason, the background has changed. Just give me one moment.
Sure.
Okay. Right.
Can you make the screen larger?
Larger? In what sense?
Presentation, is there a presentation mode on your, or?
Is this better? Yep, is this better?
I think it looks good from
Okay.
my side.
Okay, so let me start. All right. So thank you for the introduction, Peter. Good day to everyone. I'm Adrian, the General Manager of KJ Technical Services, and I'm speaking to you from Malaysia. So first and foremost, on behalf of the KJ Group, I wish to extend my gratitude to our host, the Asia Pacific Urban Energy Association and Informa Markets, for initiating this webinar and for the opportunity to speak. My fellow speakers have earlier given excellent pointers and insights on matters relating to the Vietnamese government's approach, policies on GHG and DCS potential in the region as well as in Vietnam. So I will still focus my presentation today on positioning the district cooling system as a form of service and how it can actually help accelerate Vietnam's growth, primarily with regards to sustainability. So firstly, I want to start by giving everyone a brief introduction to the KJ Group and what exactly we can offer the HVAC industry, particularly from the DCS point of view. We were incorporated more than 38 years ago in Malaysia, and KJ Technical Services have since grown and evolved from a typical HVAC contracting company into a regional one-stop center, providing a fully integrated energy and facility management solution to all of our clients. We have successfully completed and commissioned projects in Malaysia, Singapore, Thailand, China, and in the Middle East as well, namely in the UAE and in Bahrain. And on a regional scale, we have our HQ here in Malaysia, and we currently also have offices in Thailand and in Singapore. With markets beginning to open up again, we are looking to expand further, and Vietnam being one of our main target market, as we think that this market is ripe and has great potential given its rapid urbanization and economic growth. So as shared by Michael earlier, Malaysia currently has the highest number of district cooling plants in the region. It is very encouraging to see that the rest of our neighbors are catching up fast. We have gained immensely from its advantages and strongly believe this system should be adopted by our neighbors to benefit not just in terms of better efficiency and saving, but also towards a better sustainable future for the future generations. Right, so these are some of our clientele from Malaysia, as well as in Singapore and Thailand. They make up mostly our property developers, airline companies, players from the healthcare industry, the education sector, hotel owners, manufacturing, and etc. So since 2017, we have started consolidating our data. And as of 2021, that means in a period of 4 years, we found that we have managed to save 44 million kilowatt hour of electricity and more than 25 million kilograms of carbon dioxide avoided. This roughly translates to an equivalent of 1.2 million trees or 24,000 acres of forest saved. So these figures basically tell us that if everyone plays their part, we'll have a fighting chance towards a better future. All right. So now without further ado, I'll zoom in on the topic today, the district cooling system as a service. Now, in order to properly execute the provision of DCS as a form of service, we believe the adoption of the BOT model is necessary. BOT simply stands for Build, Operate, and Transfer. So under this model, we will build and operate the district cooling plant. And to give the building owner a peace of mind, the performance of the plant, including its efficiency, the flow rate, everything is guaranteed throughout the concession period. So for example, if the concession period is for 20 years, that means the client will have no worries for these 20 years. Upon expiry of the contract, all the assets are transferred back to the building owner at zero cost. Then this will enable us to function just like a utility provider. So for example, a power plant supplies electricity to its users at fixed tariff. So similarly here, the DCS service provider plays the role in supplying cooling energy at an agreed fixed tariff as well. Right. The BOT model is applicable to both the greenfield and brownfield projects. In a greenfield project, it is straightforward, whereby the DCS is constructed in accordance to the stipulated design and specifications. And upon its completion, an uninterrupted supply of chilled water with a guaranteed performance at a fixed tariff is delivered. And for brownfield projects, an energy audit will usually be carried out first to establish its current baseline in terms of efficiency and cost of production. Once the feasibility of this site is determined, the retrofit works can then take place. And upon its completion, the client will also be enjoying a supply of cooling energy from an efficient DCS with a performance guarantee in place at a fixed tariff as well. So for the benefit of the audience who aren't familiar with the DCS industry, the key takeaway pertaining to the economics of the DCS is the cost of production, or COP. So in a nutshell, it is fundamental for us to know how much utilities are required to produce 1 refrigerant ton of cooling energy. Once this is measurable, only then can we attempt to improve it, how to make it better. So ideally, you would want to pay as little as possible to gain as much cooling energy. Right. So of course, the economics of the chiller plant encompass more than just a COP, but the focus today will be mostly surrounding around the COP. And so logically, any variation in the kilowatt per RT will cause a direct impact to the COP. And we will delve into this shortly. Now, as you can see from the pie chart, typically the utility costs consumed by the DCS alone will take up more than 50% of the total utility cost of the entire development. However, with that being said, we rarely see DCS owners dedicate 50% of its operation or maintenance workforce specifically to the DCS. So if you think about it, wouldn't it make good sense to let the right people with the appropriate experience and expertise to actually manage the job instead? It is for this reason that we see the advantage of having the DCS come in the form of service as opposed to a typical build contract. So through our experience, we also come to realize that many of the DCS owners that we speak to are actually not aware or have very little visibility on their DCS's cost of production or efficiency. And this is very understandable simply because producing chilled water isn't their core business. So you think about it, McDonald's are very good at selling burgers, and Domino's are pizza experts. However, the efficiency of the air conditioning system isn't their primary emphasis. So that's where we come in. So let's go through some examples of factors affecting the COP. Example number one will be variation in demand pattern. Due to many circumstances, the cooling demand may fluctuate, and if the operator isn't technically equipped to respond to these changes, you will incur wastage of cooling energy, which basically means you're losing money. The COVID pandemic is a good example. A lot of cooling demand suddenly plunged erratically, and many operators they do not know how to respond to it. So you need to have a service provider who have a dedicated technical team with the required skill set to constantly monitor these fluctuations, and not just to monitor, but to react to them swiftly as well, so as to ensure that the DCS is always running at its optimal efficiency. Example number two will be the lack of proper maintenance. This is pretty self-explanatory. Just like the vehicle that you drive, poor maintenance will result in decrease in its efficiency and may even lead to an eventual breakdown if left unattended. So proper maintenance is crucial to ensure that the DCS sees through its life cycle appropriately. But however, we notice that many people fail to recognize its importance. And what about unforeseen breakdown? Imagine a malfunction of a major equipment in the DCS. On a worst case scenario, the breakdown will lead to a total non-supply of chilled water. So proper counter actions are necessary to mitigate this downtime. And this can only be achieved by having a reliable and capable service provider at hand. So for example, here at KJ Technical Services, we have our own in-house and maintenance team, which we can deploy immediately to respond to these breakdowns. And being in the industry for almost 40 years now, we are very close with the OEMs and the specialist contractors, and having this relationship in place is fundamental to ensure good, speedy support and also spare parts availability. We have also have in-house equipment such as chillers and pumps on standby in case that the cooling energy is needed on an ad hoc basis. So this is how we actually service our customers and give them the assurance that we are there for them, especially when times are tough. So the last example I'll use today is human error. Yes, many DCS have a running or functioning BMS system, but at the same time, we cannot totally disregard the role of the operators. Operators are humans, and like it or not, humans are prone to errors. It is also common to see high turnover in a typical operating team, and it's going to be a real hassle to keep retraining these new hires. The errors committed in a typical operating team will actually cause escalation to the cost of production, and the DCS will end up bleeding dollars and cents from these losses. So because this is our bread and butter, we have a pool of certified technical staff which are very regularly trained for improvements, and their know-how will prevent these errors from happening in the first place. In addition, we don't just rely on the operators at the site. We also have a 24-hour command center in our HQ to constantly monitor the performance of all of our DCS plants. So if anything improper were to occur, it will not bypass our double-tiered operation and monitoring structure. So the point I'm trying to drive here is that to give the client a total peace of mind, the service rendered under the DCS must be through a holistic approach, whereby we walk the talk, we bear the risk, and we contractually guarantee the performance of the DCS. We cater to everything from the conception of design to construction and commissioning, and then the subsequent operation and maintenance of the DCS. And if it's a BOT concession, all the assets are then finally transferred back to the client at the end of the contract period. We can also play the role of the investor, be it minority or majority, depending on the preference of the client, for the construction capex of the DCS. By having skin in the game, the client can be rest assured that we put our money where our mouth is in the very literal sense. Right. So by engaging a capable service provider, the client can rest assured that the quality of the executed works are as specified or even better. There'll be no cutting corners. in terms of work quality, because it will be in the best interest of the service provider to ensure that the DCS is built, operated, and maintained to its best possible potential. Otherwise, with the performance guarantee at stake, the losses, if any, will be eventually borne by the service provider itself. So confidence to the client can be further enhanced if the execution of all that I've just said be done transparently and graded based on predetermined KPIs that is agreed by both parties. So an example of this will be the vital parameters such as the plant efficiency be made accessible instantaneously to all parties, including the building owner or the client. So they basically have an access to this information at any place and time. So as a result, the client will then be able to enjoy an uninterrupted supply of cooling energy produced from a well-built DCS, minus the risks and liabilities that is normally associated to a conventional construction model. With a fixed tariff in place throughout the concession period, it allows the owner to also properly plan its DCS-related cash flow without any unwanted surprises. So as shown in one of my earlier slides, if the service provider is investing in the CAPEX, the owner can then channel the funds initially intended for the DCS construction into his core business instead. And to go one step further, the owner can also turn the DCS into a business and sell any available or surplus cooling energy to customers within its development, and then to increase its revenue. So this way, I guess everyone wins. So to better illustrate what I've just mentioned, I shall use one of our completed projects recently as a case study. So, okay. So this particular project is for a 20-year BOT concession, which is typically the life cycle of a DCS plant. It is to supply chilled water to an education hub comprising of 4 university buildings and a common shared facility, including the underground distribution network piping, which is about 3 kilometers long. KJ Technical Services have invested 65 million ringgit, or an equivalent of 342 billion Vietnamese dong, into the construction of this plant. Right, so we commissioned and completed the construction in 2016 and have since operated and maintained the plant up to today. At peak, it is able to supply about 7,900 RT worth of cooling load. And what you see here on the screen are the actual photos taken from the plant. Cooling towers on the left and the process pumps are on the right. Okay, so just like all of our BOT contracts, here we guarantee parameters to the client, such as the plant's efficiency, the cost of production, the chilled water supply temperature, water quality, and etc. And any deficiency is subjected to penalties. And one notable feature of this DCS is that it includes the installation of 2 numbers of chilled water tanks with a capacity of 20,000 RTH each. These tanks are actually shown on the right of your screen at the moment. So with this installation, as shared by Young Wei earlier, we are able to benefit by utilizing a special electricity tariff from the electricity provider. Basically, what we do is that we run the chillers at night to charge up the tanks with the purpose of storing the cooling energy into those 2 tanks that I mentioned earlier. So we actually save from the lower utility charges imposed throughout the charging duration. And what we do is that we discharge the cooling energy during the day when there's a demand for it. So this way, we can actually supplement the required cooling load instead of having to run all the chillers, which will be more costly. And during the COVID pandemic, the load demand was low. So we were actually able to supply chilled water purely by discharging from these tanks alone, resulting in very, very considerable savings. So these kind of practices we have tried and tested for over the last 20 years here in Malaysia, and we know that it works. And we are very confident that it can be replicated in our neighboring countries as well. So as you can see here, this way, despite the fluctuating cooling load profile, which is represented by the line in blue, we can see that the total kilowatt required is pretty flat. So this will lead to rather significant savings from the incoming supply, the maximum demand, the declared peak power usage, etc. And the savings will be amplified, especially over a long period of time. Now, to summarize, so these are some of the key takeaways from my presentation today, some of which I will reiterate from earlier. So unlike a typical build contractor, having the BOT concession in place mitigates all the risks which a client would normally have to undertake, especially after the defect liability period has expired. Also, being an energy management company, we will continuously focus on implementing energy saving initiatives. An example, we're adopting the latest benefits from IoT and the AI technologies to complement our DCI system, even if it means an increase in initial investments on our part. Why we are doing this? Because through our experience, we are confident to see tangible and intangible returns during the operation period. And the savings will then benefit both the client and the service provider, such as ourselves. As the DCS is a centralized system, and through the economic of scale, the typical number of equipment and operating manpower are reduced if compared to having individual chiller plants for each building within the development. And this will then lead to savings if required in required investments. And last but definitely not least, it's also a conscious effort to reduce carbon and noise emissions, which is in line with the current initiative to drive for a better sustainable future. So that's it from me today, and I hope the information I shared have been useful. I will wrap up by thanking everyone in the audience for your kind attention, and again to our gracious hosts from the APUEA as well as Informa Markets. Thank you, and back to you, Peter.
Thank you, Adrian, for that comprehensive presentation on the topic cooling as a service. I think you provide a lot of insights in what is possible to do in terms of the business scope of cooling as a service, but also the benefits of district cooling. And I think we are quite inspired here to see what can be done here on the Vietnamese market. So thank you, Adrian. So with that, I want to wrap the presentations and want to move on to the Q&A session. I want to remind everyone that you can write questions in the Q&A box. And please remember to write the name to the speaker you want to ask the question to. I think I want to bring up all the speakers. So I think the speaker can turn on the camera and so we can see you all. And then we will start here. I think that we get some questions here on the potential of district cooling projects in Vietnam. So I think there's a general question that maybe all of you can address, and maybe I start with you, Michael, to take in order. Michael, so how do you see the potential for district cooling projects in Vietnam and also in ASEAN countries?
Yeah, so I think we got a great introduction here from the representative of the ministry that there are really things going on in the market, and obviously that there are national drivers here also, both in regards to that the NDCs have been enhanced, but also what we see around here is increasing energy prices, and we get reminded about energy security, which is really important, and to be future-proof. That we should remember with district cooling, that we are not locking ourselves into a certain fuel necessarily. We can apply different kind of technologies. We can use waste heat. We can use many different technologies when we have these infrastructure up running, and then of course getting the synergies with other things. We see the benefits of releasing the stress of the electricity market, which obviously the awareness is rising a lot recently. And I would also like to just make a reminder that in the beginning I said that the economies in the region are quite diverse. Vietnam is, good in that aspect that there is a history of planning. There is a history of the public sector being active and so on. And as long as the public sector is active, supporting, promoting and accelerating the development, that makes definitely things easier. So I think that Vietnam will be a very, very interesting market to look at ahead.
Great, thank you very much, Michael. I want to move on to Dr. Lung. Are you there?
Yes.
Okay. Yes. So I would like to ask you the same question. So, like maybe two questions. So, how do you see, the potential of district cooling in Vietnam, and also, are there any specific studies to pin down, the size of the cooling market in Vietnam, or is something that is available today?
Well, I'm not really an expert in this particular area, but I can give a little bit of insight from the perspectives of what we are working on in terms of the policies to achieve net zero or GHG emission reduction in general. First of all, in terms of the market for district cooling equipment, as I have seen, and from what I discussed with colleagues, is increasing a lot in recent years, and expecting that is going to increase even more in the next decade or so. And with the urbanization in Vietnam now, then the rate is quite high, and there's but also there's an opportunities to improve with the current situation in terms of energy use, in terms of the efficiency of not only the equipment but also the process and the design and the planning as well of this recalling system in Vietnam. But that requires, first of all, is the political will, that in the form of policies, and which we already have in some certain aspects there in terms of, as I said, in terms of climate change policy, for example, and also in the particular energy sectors and even building sector as well. But the most important thing here, I think, is the participation of private sector. They need to understand why they're doing that, and what is in it for them. And it's my colleagues here, for example, when doing with the F-gas management, that it takes a very long time for the companies, for the project owners, or to understand the significance of what they are doing and what we are working on for now, and that will bring them the benefits for a long term. So that's just my 2 cents of thoughts there, and I think I'm not an expert in this area. Yeah. Thank you.
Thank you, Dr. Lung, for that. No, but I think your answer is very interesting, and it highlights a lot of the thoughts that we are also having on the topic. Yeah. So okay, let's move on to Young Wei. So can I repeat the question to you as well? So how do you see the potential of district cooling in Vietnam, in regards to your previous experiences in the region?
So for Keppel, Vietnam is a huge potential market. So our Keppel Lab Vietnam has a huge presence in Ho Chi Minh City. So we are very optimistic on Vietnam growth in terms of development in the next coming decades. So we have explored a few projects in Vietnam. This covers townships development in terms of mixed-use integrated township, and most of the projects are very interesting. So in terms of diversity, and also the project in terms of saving for district cooling potential is huge because of the diversity of use in that mixed-use development in the township, and then also for industrial park. I think those are all very interesting projects. I think with Dr. Loon sharing on what Vietnam plans to push ahead with reduction in greenhouse gas and also for ozone mitigation plans, I think that will give a very big booster to what DCS can achieve in the next coming years. I think very optimistic.
Thank you, Young Wei. Adrian, the same question to me.
Okay. So in Vietnam, as well as the similar countries in the ASEAN region, the urbanization growth percentage is just steadily increasing. The demand for cooling energy is at all-time high today, and as what everyone agrees that it will be even more tomorrow. Cooling is no longer a luxury, but it is a necessity. So one way or another, there has to be a way to feed this demand. So as Michael has presented earlier, for cooling supply under a broad range of applicable requirements, DCS is the best way to go about it, be it from the aspect of efficiency, dependability, and also cost savings. And for Vietnam, many of these applications or many of these potential actually fall under these categories. We also have to consider that the emissions due to the increased cooling demand will rise as well. So DCS will actually help reduce the rate of emissions and also cut the carbon footprint. The Vietnamese market is right. We recognize this as mature enough to adopt this. And because we have seen this being successfully being implemented in Malaysia and subsequently replicating its accomplishment in Thailand and Singapore, we are very, very confident to see this happening, and hope that we can also play a role in helping Vietnam to achieve this for a win-win situation for everyone.
Thank you very much, Adrian. I want to move back to Michael and Dr. Lung. I mean, you touched on that already, you know, that the importance on, let's say, both, you know, public and private sector to working together, and maybe also the private sector to get involved in the district cooling development. So if I start with you, Michael, then how do you think capacity building and raising awareness of district cooling can help to accelerate the development of projects in Vietnam?
Yeah, sure. I mean, like I touched upon before, obviously, I mean, awareness rising and skills are of great importance. And I mean, to put it in perspective across the region, me, myself, being involved in many developments, myself, but also seeing other developments, what we're talking about here is whether we have a life cycle of a district cooling scheme of 15 years or 50 years. So, I mean, skills is really important. Quality along the whole project process, along the whole system value chain. So to understand this and really apply great quality management is really, really important. And that goes through the whole value chain simply. So it is super, super important. And here we need different kind of capacity building, and not least from both KEPL and KJTS that we have with us here today. It is to share the experiences. We have to understand that localization is of great importance. It's really, really important. It is to have experience from the local markets, regional markets. Every sector, I mean, every district cooling sector or market is different. It's different from city to city. So the more like experiences you have from similar business environments, the more you can benefit from that. So I think it's one of the keys that we see here these years. I mean, having these kind of private sector players being here ready to undertake these projects and develop the projects will benefit a lot, because the skills, and we have to remember that these projects that we have seen here today, they are international best practice. It is really, really good systems. It is really the skills that is needed. So it's really positive that this is available. That was not the case 30, 40 years ago, really. Now it is here. So it's very, very good and that then you can say is also the ones who can bring in skills for the capacity building as well. So we as a sector association, sure, we will do our part, but we will also bring in the real experiences.
Thank you, Michael. Dr. Lung, would you also like to comment on, let's say, the need for capacity building, to discuss how to meet the growing cooling demand and the importance of energy efficiency and making the private sector and the public sector meet and discuss these topics?
Yeah, I think the capacity building needs is always there. It's always there for especially for private sector or in fact for all relevant stakeholders. I understand that under the VN EAP program, which is the program that implements the law on energy efficiency and conservation in Vietnam, it's been going on for the past 10 years. They've been doing a lot on capacity building, on energy efficiency, and some of them would be on district cooling. They didn't call it district cooling by the time, but it's in general it's for all types of energy use. But I think that is a problem, because if we need to focus on district cooling, we need to tailor-made to have a tailor-made capacity building for all the relevant stakeholders, with that focus on the district cooling system and equipment and what kind of activities that can improve the energy use of that area in particular. And just my thought on that. Thank you.
I think, Michael, did you have another comment?
I think it's a great comment there that Dr. Lung was saying, because that's what we have seen also. It's about the terminology and definition. Also one of the reasons why we choose Asia Pacific Urban Energy Association, because you know, we did a study a couple of years ago where we asked, and I think I told this anecdote several times, where we interviewed some 20 professors across the region whether district cooling was feasible or not, where half was extremely confident that it was feasible, and the other half, they were so skeptical. And then when we start to dig into what we actually are talking about, everyone was agreeing that district cooling is feasible, because it depends on the definition. So it is called different things, all from centralized cooling to, you know, city-wide cooling systems. There are many different definitions that people interpret district cooling differently, and that we have to keep reminding that all we're talking about here are centralized systems that are feasible. Otherwise, we will not develop them, of course. I mean, it's not in anyone's interest to develop systems that are not feasible. So it's a very good point, and we have to work more on this to, how to say, use the same language. We have had a great dialogue with UNEP on this, that we should use the same terms as we have these different initiatives going on in parallel and in collaboration, but also independently, that we try to use the same terminology. It's really important.
Thank you, Michael. I have one question more for you, Dr. Lung. Is there any are you aware of any specific policies that support district cooling in Vietnam at the moment, or is that something that might come in the near future, if not?
I believe there's quite a number of policy in terms of energy efficiency is already there in place, but that needs to be updated in the context of, first of all, that what we are working on here in terms of district cooling, and also transition to achieve the net zero goal. But still, is within the Vietnamese legal system, it needs to come from the law, and we already have the law on energy efficiency and the law on environmental protection, which is on climate change, as I presented to you already. And under the law is a different types of decree that focus on specific issue. And because of this, cooling is also related to a lot of the system of standards on building sector as well. So that's some sort of synchronization of all the legal system that we have here. So I think we need to have first of all is inventory on the legal system, and then also find out what the gaps and what would be needed for district cooling in Vietnam.
Thank you very much. Thank you very much for that. Yeah, so we have a few technical questions here. I'm not sure exactly who they are for, but let's. I think I mean, it's Young Wei or Adrian here. So, so when it comes to running the wrong equipment, can you please give a specific example on this issue? I think it's Adrian, if I'm not mistaken.
Right. You mean running the wrong equipment in what sense, Peter? Okay, one of the common issues, because we are privileged enough to actually having to work with some of the biggest developers in the country, right? So they hire consultants in to do a master development plan, and we actually see that the planning isn't as it should be, especially when it comes to DCS. So again, I think the money shot is to be as transparent as possible to these clients. We are not there to take advantage. We are there to work together with them to collaborate into building the most efficient system for the mutual benefit of both parties. So we need to get the first step right, then it's easier for everything else to fall into place later. So one of these examples is we normally like to sit down with the client to really understand their requirements and need before even providing any conceptual design